Hello everybody, it's been a while. Summer school just started and I was having a lot of technical problems, and I still got a couple more technical problems to deal with, but we're actually doing pretty good here. So as you can see, right now that's actually just holding it by the spring force, and we have the arm set up. This area I'm looking into changing. It's just on a really weird spacing, so it's going to require a little bit of reworking. Right now these are having too much twisting, so it's pivoting around this, but after many tries and iterations and attempts, I finally figured out how to make this gearbox work. What had happened was originally the turntable bearings were right here, and so I could run the gear train down the side and then put the motors on the outsides down there, but now I can't do that because everything's on the outside and that would interfere with that. And on the inside we have both of these chains and sprockets, and so that was going to be in the way. And I went through a bunch of stuff where I was trying to put gearboxes in here and there wasn't quite enough room, and I was getting alignment issues. Eventually what I just figured out was these are the actual worm gear brackets. So these are worm and wheel, and then they're leading to bevel gears, and I have these two running in parallel, and so these rotate in opposite directions, but because the bevel gears are in the two different directions, they end up making the shaft rotate in the same direction. Then on either side, in order to get that back up and over, we have the 12-tooth pinion to the 36, I believe it is, as an idler, to a 60-tooth as an idler, and then finally that comes up to the bearing, and I have the same thing on the other side. And then for the shoulder and the wrist, these are both just 3 times gear ratio sprockets, and then each side is 2 worm and wheels linking them up, which 24 times gear ratio on the worm and wheels. So 24 times 3, 72 off the top of my head. And then these ones are on a 5 times ratio. So 120. If my math is wrong, forgive me. I'm not paying attention. So I rigged up my buttons again, and then I've just been playing around with it, and I can show you what it's actually doing. So there's shoulder, elbow, and wrist. All right, 3, 2, 1, lift off. Whee! One of my motors is turning. There we go. So as you can see, again, I've got the even bar linkage set up with the sprockets, so once I set the pitch to the correct angle, I don't actually have to change it. The same thing actually happens with the elbow joint, which is not an advantage, but is livable. Eventually that'll just be corrected in the code. As you can see, so those two joints are working very well. It actually is moving pretty rapidly, given the size of the VEX motors and the load. That's an unopened pop can. See if we can get this. So as you can see, even through that point of maximum torque, the motors aren't straining that hard. And even more fun is the fact that I'm running this off of the little battery, and that one I've had plugged in for a couple days, so I've been using that. So that's not even a fully charged battery, and it's still running well. And I do know from experience, even though it may not seem like it, the 3000 milliamp battery gives it makes the motors actually run a little bit faster, or at least have a little bit more juice available. So I'm going to lower that down, and then I'll show you the pitch. So here's the pitch. Nope. No, pitch strains just a little bit. So you can sort of see here what I've done for this, and this is part of the reason why it's so wobbly right now, is I just took those two angle brackets, and that one I ran a single bearing because this is going through this, and these are actually attached to each other. The bearing itself is screwed onto the sprocket. And then this one has a double bearing because this is just the shaft resting in there. And heart attack. So this has very little clearance, but there should be I should be able to bundle the wires together and run them down along the center. And then see if I can get a view. This is subject to change, but as you can see, I've got these two limit switches here, and I might actually play around with these a little bit more to see if they're steady enough with only one screw attaching them. Right now, if you look at it, you can see how those two screws are there. One of those is interfering with the bracket, and that prevents the claw from closing all the way. But at the moment, the way I have it set up with these limit switches is this one has its lever positioned around the claw, so that's the product detected switch. if there's something in the gripper area when the claw closes, that limit switch is triggered, so that way the robot knows that it's actually picked something up. That other one, I kind of cammed out the limit switch so that once the claw closes as far as it can, it trips the limit switch. So that's the claws all the way closed signal. And I would have loved to do something a little bit simpler. Like if I could have, I would have used a potentiometer. But this whole thing is just an absolute mess when it comes to trying to actually work anything useful in, like a potentiometer, because none of these holes are on proper spacings for integrating with the gears. But other than that, you know, it works, it holds it. Again, that doesn't even have the motor on it, so the springs on these guys are actually very nice, and things are working quite well. The bearings, I added in 2 more beams because as it was not resting. What was happening was there was so much torque on that metal plate that it was just twisting it up, and it was making this thing bend. I mean, it's already bending quite a bit, but it was really bad before I added those in. And I think that's about it. So progress is still working. There's room for more sensor. Next step is going to be to try and work in my potentiometers. I'm probably going to go over on this one for the shoulder joint. I'll put the potentiometer up there, and then I'll try and work in the wrist joint potentiometer somewhere around there, and the shoulder joint somewhere around here. Then the yaw potentiometer is down there. The linear slide base has an integrated motor encoder. This stupid thing has an integrated motor encoder on it. I'll have to get some kind of tripping mechanism up there to get it to reset. And then there's redoing this. So plenty of work to be done mechanically, but we're hopefully getting a little bit closer to being done with the mechanical side, and we can start having some fun. By the way, Dr. Pepper, you owe me. Dr. Pepper, you make the world taste better. All right.